Hello everyone and welcome to Chinese remainder theorem tutorial. On this module you will be given a bunch of equations that are supposed to be up to eight equations, but my module hasn't been updated yet. So your goal is to find the n number that satisfies all of these equations. I expect you to know what modulo is and how it works. Otherwise, how are you going to learn this module? There is a manual that explains how to do the algorithm. It's in Cipher Machines somewhere. Chinese remainder alternate by Eltrick, this manual. And it's this part, finding V from two modulo and remainders. It's for two equations only, but in our case there are more. Oops. So let's write down the equations. So we got a bunch of duplicates, so we can get rid of some of them, and I believe that's it. And by the way, this equation is implication of this equation. As you can see, if n modulo 24 is 15, then it's going to be always be divisible by 3. So we can get rid of this equation. That leaves us with these 6 equations that I'm going to sort in descending order of the moduli. So 46, then 39, then 37, 35, like that. First thing we do is take the first equation and rewrite it in this form. It's basically 17 remainder plus modulo times some number, some integer a. Okay, we take this equation and I will mark it down that we used the equation, and we take the next one. So n is equal to 9. It was modulus by 39. I'm writing modulo on the right side just for the convenience sake. Next thing, now our goal is to solve for a. So basically on the left side we need to have just a and something on the right side. So for this we are going to first subtract this number from both, the remainder from both sides, which is going to give us -8. Now add to this number 30 the modulo until this number is in the range from 0 to 38. So it's going to be 31. And now for the convenience, since 39 times 8 is always going to be divisible by 39, we can just subtract 39a or add 39a as many times as we want. So I'll subtract one time. Now our goal is to make this number divisible by this number. So we're going to repeatedly add the modulo. So 31 plus 39 is going to be 70. So 70 is divisible by 7, so we divide both sides by 7, which gives us 10. So a modulo 39 is 10. We rewrite this equation in this form and make a new variable b. Substitute it into this main equation, open brackets. So it's going to be 460 plus 17, so 477 plus 6 times 39, 1794 times b. Okay, we used this equation. Now take this new equation and do the same again for the third equation. Take the main equation and do the same step for the next unused equation. So it's going to be 17 and it was modulated by 37. Subtract 477 from both sides. And then try to make it in the range from 0 to 36. 37 times 13. So 13. So it's going to be 21. And from this number, we're going to subtract 37 until it is as less as possible for convenience. No, it's too much. 40, 47, 48. It's going to be 18. Now we're going to add 37 to 21 repeatedly until it's divisible by 18. So I will make this thing 21 plus 37 times something, and we will check if it's divisible by 18. So let's start 1, 2, 3, 12, 14, 15. So now it's divisible by 18, and the number that we got on the right is 576. So 576, and we divide both sides by 18, which gives us 32. So b is 32 plus 37 times some c. Substitute it in the main equation and then open brackets. 477 plus 1794 times 32 equals this, and 1794 times 37 is this times c. So we used this equation, we're into the next one. Is equal to 31, and it was modulated by 35. subtracting 5785 from both sides. And trying to make it into the range of 0 to 36. Sorry, 0 to 34. Try like that for 3. It's going to be 1, and then from this number trying to make it as low as possible. 2000, no, 190, 180, 1890, 95, 96, so 96, so it's going to be 18. And now adding 35 until it's divisible by 18 makes it 36. This is divisible by 18, so dividing by 18 gives us 2. So C is 2 plus 35 times B. Substitution gives us this equation. Opening brackets 57885 plus 66378 times 2 and times 35 times D. Okay, 2 equations left. Next is 15 and it was modulo by 24. So 15 minus 190 okay, now putting it into the range of 0 to 23. How many times? 7,000, 8,000, 790, 950, 48, 46, 44, 43. Gives us a number of 6. So now getting it as low as possible, subtracting 24, $30. And we can subtract 24 once again, which gives us 6. And we can actually divide both sides by 6 now, which means D is 1 plus 24 times E. Substitution gives us this equation, and opening brackets gives us this plus this times 1, which is this number, and this number times 24, which makes the equation look like horribly like this. And the final 7th equation, so this is 9, and it was modulated by 13. 9 subtracting this huge number gives us this huge number, and we add 13 how many times? 1, 2, 3, 4, 5, 6 1, 2, 3, 4, 5, 6. Okay, 5, 4, 5, 0. Very close. Zero. Just realized we could actually just all this time we could actually apply the modulo operation to this number without doing it ourselves. Sorry for inconvenience, but now you know. So now we take this number modulo 13 and also get 0, which means that this equation does not this equation could actually be removed because it is an implication of some other equations in this list, so we can safely delete it. So now we got our final equation. This is the final form of number n, and e is any integer. So as long as e is any integer, this whole number will be the answer. Let's take e as 0, which means this number is going to be the answer. 2, 5, 1, 3, 8, 7, 1. Thank you for watching. Oh, by the way, if you input a wrong number, the whole thing is going to strike and generate a new set of equations and a new number. And anyway, thank you for watching and have a nice day.